Pratima from Planet Physiology. In this video, we shall learn about cardiorespiratory and metabolic adjustments during exercise. This topic will be dealt under the following headings: Introduction, Types or classification of exercise, Gradations of exercise, Acute changes during exercise, and Effect of training. What is exercise? What exactly it means? Exercise is any planned, structured and repetitive physical activity performed to enhance or maintain physical fitness, overall health and wellness. This science is such a vast science that there is a separate branch of physiology which specializes in exercise. It is called as exercise physiology. It deals with study of acute responses as well as chronic adaptations to exercise. Whenever we think of exercise, we imagine various different exercises. So let us study what are the types of exercises. Exercises can be classified based on various factors. According to the type of muscle contraction that occurs during exercise, it can be isotonic, it can be isometric exercise, and the third type in this category is isokinetic exercise. Isokinetic exercises are performed with the help of machines. They change the resistance offered to the muscle as we perform the movement. According to the purpose of exercise, exercises can be classified into 5 categories like endurance exercises, which are performed to enhance the stamina of a person, and usually all aerobic exercises fall in this category. Second category is strength exercises or exercises performed to enhance or build the strength of the muscles. The third is flexibility exercises. Next is agility exercises and exercises for improving balance. Even though there are different types of exercises, not a single exercise is perfectly done with the same purpose, and there is considerable overlapping of the exercises. For example, any exercise which is performed to increase flexibility automatically involves balancing also. For example, most of the flexibility exercises are stretches or the yoga, so automatically balance is involved. Similarly, in agility training, there will be endurance training. The third way by which exercises can be classified is according to the availability of oxygen to generate energy during the exercise. It can be aerobic or anaerobic. In aerobic exercises, as name suggests, oxygen is available and ATP are produced by oxidative phosphorylation of various substrates. Whereas in anaerobic exercises, intensity is such a high that oxygen supply is not sufficient to generate enough ATPs, and therefore ATPs are produced by anaerobic glycolysis process. So let us study a bit detail about these two types of exercises. Starting with aerobic exercise. These exercises are low intensity, high duration exercises and done with repetitive rhythmic activity of large muscles. These exercises are mainly performed to improve or maintain cardiovascular fitness, and therefore according to gym language they are also called as cardio training. It is also called as endurance training exercise. These exercises work best when they are performed in the range of 60 to 80% of the target heart rate. So what is this target heart rate? Simple calculation. Just subtract your age from 220 and that is your target heart rate. And if you calculate 60% of this target heart rate and 80% of the target heart rate, any exercise done in this range of 60 to 80% will give you best results for developing endurance. Usually, aerobic exercises utilize carbohydrates as well as stored fat to generate ATPs, and therefore they are also helpful in weight loss programs. Few examples of aerobic exercises include jogging, cycling, swimming, dancing. You can think of any activity that can be performed with low intensity for longer duration. In contrast, anaerobic exercises are high intensity, short duration exercises and usually involve sudden burst of muscle activity. These are mainly performed to improve or maintain muscle strength. The predominant energy source for these exercises is stored glycogen in muscle. Examples of these exercises include 100-meter dash, weightlifting, high jump, long jump, etc. Whatever is the type of exercise, its intensity will be decided by certain factors, and according to these factors, exercises will be graded as light, moderate, heavy, very heavy and maximal. Now for gradation, three factors are considered. First thing is oxygen uptake in liters per minute, then power output in terms of watts, and third is heart rate per minute. Now out of these three, heart rate is a very simple parameter to grade the exercise, and we will study this in detail. If your heart rate raises above resting level but it is up to 100 beats per minute, exercise is considered as light exercise. During exercise, if heart rate is between 100 to 120, it is moderate exercise. If heart rate increases above 121 but it is less than 150, exercise is termed as heavy exercise. If heart rate is between 151 to 175, it is called as very heavy exercise, and if heart rate goes beyond 175 per minute, then exercise is called as maximal exercise. Now let us study about changes that take place during exercise. These changes we can classify into two: acute changes and chronic changes. Acute changes are the changes taking place during exercise, and these are usually systemic changes, and these changes are mainly directed to maintain appropriate level of homeostasis during exercise. Chronic changes are long-term adaptive mechanisms that take place due to continuous exercise programs, which is called as effect of training. These adaptive changes are directed to improve efficiency of homeostatic mechanisms during any disturbance. These changes during exercise depends on type of exercise, gradation of exercise, climate in which exercise is performed, physical status of an individual, gender as well as age of a person. Now, because these changes depend on type of exercise and intensity of exercise, in this session we are going to concentrate only on those changes which will take place during moderate aerobic type of exercise in a normal healthy individual. During any aerobic exercise, as we have seen earlier, there is increase in muscular activity of many muscles in the body. As a result, there is increase in oxygen as well as nutrient demand. Also, there is increased production of carbon dioxide, heat and other metabolic waste products. Both these factors bring about systemic changes in such a way that appropriate level of homeostasis will be maintained. That means muscles are made available with increased oxygen as well as nutrient, and at the same time they are getting rid of all the metabolic waste products. All these changes are mainly achieved by sympathetic stimulation. So here the key factor to remember is during exercise there is sympathetic stimulation, and all the changes whatever you see during exercise are because of this sympathetic overactivity. The first line of response during exercise is to increase heart rate, respiratory rate as well as depth of respiration, so that both these factors, increased oxygen demand as well as need to eliminate more amount of carbon dioxide, will be fulfilled. So let us see these changes. We will start with the cardiovascular changes during exercise. Whenever there is sympathetic stimulation, as also in exercise, there will be increase in heart rate as well as force of contraction of cardiac muscle. Increased force of contraction of cardiac muscle will increase stroke volume. Increase in heart rate as well as stroke volume will lead to increase in cardiac output. This cardiac output increases in a linear fashion as rate of exercise increases. Cardiac output is the determinant of systolic blood pressure, and hence systolic blood pressure also increases during exercise. The purpose served by this increased cardiac output as well as systolic blood pressure is to increase blood flow to exercising muscles. What about diastolic blood pressure? During moderate aerobic exercises, there is no change in diastolic blood pressure, or actually the diastolic blood pressure may even decrease. We have seen that there is sympathetic stimulation during exercise. This will also act on systemic arteries to cause vasoconstriction and will increase peripheral resistance and lead to increase in diastolic blood pressure. But at the same time, sympathetic stimulation will also act on the arterioles in skeletal muscles and will cause their dilatation via beta 2 receptors. So it is the balance between these two: systemic vasoconstriction leading to increased diastolic pressure and skeletal muscle vasodilatation leading to decrease in diastolic pressure. These will nullify each other and the diastolic pressure will be maintained normal, or there will not be any change in the diastolic blood pressure. So this is about moderate aerobic exercise. But if the person is performing any isometric type of exercise, then definitely there will be increase in diastolic blood pressure. So please remember, effect of exercise on diastolic blood pressure will depend on the type of exercise. Usually in aerobic exercises of moderate degree, there will not be any change in the diastolic pressure. But in case of isometric exercises, diastolic blood pressure will definitely rise. And this is the reason why during the cardiac rehabilitation, isometric exercises are not suggested, but importance is given only to mild to moderate aerobic exercises. Then what are the effects seen on various regional circulations? We will start with coronary circulation. Now as we have seen, heart rate has increased, force of contraction has increased. That means cardiac muscles are performing more work than resting, and therefore there will be increase in the coronary circulation. This is in direct proportion to the workload on the heart. And what is the effect on pulmonary circulation? It also increases. We have seen there is increase in the cardiac output, and entire cardiac output goes to pulmonary circulation. So pulmonary circulation also increases, and the main purpose of this increased pulmonary circulation is to obtain more amount of oxygen and to remove extra carbon dioxide. How it is achieved? First thing, all the apices of the lungs, they are converted to zone 3 blood flow, as well as there is capillary recruitment, and both these factors will help in increasing pulmonary circulation. In case of skeletal muscle, there is increase in the blood flow by 4 to 5 times the resting state, and this is mainly to fulfill its increased oxygen and nutrient demands and to remove the metabolic waste materials like lactic acid and heat. Now if you study what happens to cutaneous blood flow, initially there is decrease in the cutaneous blood flow just to divert the blood to the working muscles, but as exercise rate increases or duration increases, heat production increases and there is cutaneous vasodilatation just to remove heat, and this is called as sweat based thermoregulation. During resting state, skeletal muscle blood flow as well as cutaneous blood flow is about just 20% of the cardiac output, but during mild to moderate type of aerobic exercises, this blood flow increases to 80% of the cardiac output. Just to give you an example, a male marathon runner loses in each hour around 0.8 liters of water in cool weather and 1.2 liters of water in warm weather. With this you can understand how much increase in cutaneous blood flow takes place during exercise. And this is the reason why it is essential to maintain hydration state during exercise. Now what happens to cerebral blood flow? It also increases. There is higher oxygen as well as glucose demand to maintain motor control. And it is said that even though brain depends on glucose for its energy, during exercise, lactate is providing about 1/3 of brain's energy demand. Next is blood flow to gastrointestinal tract as well as kidneys. Blood flow to both these organs decreases, and the purpose is just to divert the extra blood from these two systems to the working muscles. So these were all the cardiovascular changes seen during exercise. Now let us study respiratory changes that are taking place during exercise. Respiratory changes are taking place due to three factors: sympathetic stimulation, stimulation of various proprioceptors, and increase in body temperature. All these factors increase rate as well as depth of respiration, leading to increase in alveolar ventilation. Also, we have seen that there is increase in pulmonary blood flow. So, increased ventilation as well as increase in pulmonary blood flow will facilitate increased oxygen uptake as well as carbon dioxide removal. Now, let us study about metabolic changes. Exercise involves muscle contraction, and contraction requires energy in the form of ATP. Whatever is the stored amount of ATP within the muscle that can provide energy only for 2 to 3 seconds of contractions, and for continuous activity there is need to resynthesize this ATP. So this resynthesis of ATP takes place by various mechanisms like phosphagen system, glycogen lactic acid system, and aerobic system. In phosphagen system, ATP is produced by breaking down creatine phosphate in the muscle, and therefore this system is also known as ATP creatine phosphate system. As this is the immediate source of energy, it is also known as immediate energy system. So as soon as muscle contraction begins, creatine phosphate within the muscle is broken down to creatine and phosphate, and this process releases 10,300 calories. Out of these, 7,300 calories are utilized to produce ATP from ADP. Stored ATP plus ATP generated by breaking down creatine phosphate can provide energy just for 8 to 10 seconds of muscle contraction. Say for example, intense short duration activities like weightlifting, long jump, high jump, etc. The next mechanism is glycolytic system, which is also called as glycogen lactic acid system or short-term energy transfer system. In this process, stored glycogen within the muscle is broken down to glucose and then to pyruvic acid. In absence of oxygen, pyruvic acid will be converted to lactic acid, and this process will generate 4 molecules of ATP. This anaerobic hydrolysis of glycogen is sufficient to provide energy for about 1.6 minutes activity. During any moderate intensity exercises which are lasting for less than 20 minutes, about 20% of the energy is obtained by glycogen lactic acid mechanism. In case of any prolonged activity, there should be continuous supply of ATP, and it is possible only by oxidative phosphorylation of foodstuffs. So this system is called as aerobic system. The main substrate utilized during oxidative phosphorylation is carbohydrates and fats. Glucose will be broken down to pyruvic acid, and pyruvic acid in presence of oxygen will enter in Krebs cycle to produce ATP. During this process, 38 molecules of ATP will be generated by hydrolysis of single molecule of glucose. If the substrate is fatty acid, 460 ATP molecules will be produced by utilizing one triglyceride molecule. Thus, for mild intensity, prolonged activity, glucose and triglycerides will be utilized. Now, the substrate availability to the muscle is integrated at 5 levels. First, by sympathetic stimulation, then by endocrine response, then substrate availability in the body by regulation of muscle blood flow to provide the substrate, and the local cellular factors which will increase cellular uptake of the substrate. Under normal resting situation, about 50% of the glucose is taken up by central nervous system and 15 to 25% by blood cells, mainly RBCs, and then by kidneys. And this glucose uptake is non-insulin dependent uptake. At rest, only 10% of the glucose is utilized by skeletal muscles, and this glucose uptake by skeletal muscle is insulin dependent. Normally, skeletal muscles utilize fatty acids as their energy source. During exercise, there is rapid increase in energy demand. Sympathetic stimulation during exercise also initiates glycogenolysis within the muscle, and this glucose will be either utilized by anaerobic or aerobic mechanisms depending upon the intensity of the exercise. This is very important till the increase in the muscle blood flow takes place. Once there is increase in the muscle blood flow and there is stimulation of glucose uptake by the muscle, glucose will be utilized by oxidative phosphorylation mechanism. Sympathetic stimulation also activates lipolysis, causing release of free fatty acids and glycerol, and these products are mainly utilized for gluconeogenesis in the liver and also for oxidative phosphorylation. So, substrate available are either glucose and free fatty acid. Now, which substrate will be utilized by the muscle? It will depend on intensity as well as duration of exercise, prior physical training of a person as well as prior dietary intake. When a person is performing at 50% of the VO2 max, the requirement of glucose and fatty acid is 50-50 each. When intensity of exercise reaches 75% or above, then muscles are mainly dependent on glucose. The initial 60 to 90 minutes of exercise, glucose uptake will increase, but later it will be mainly fatty acid oxidation. So, even though muscle glucose uptake has increased, blood sugar level will be maintained within narrow range. Only exception for these conditions are two. During very high intensity exercises, there will be increase in blood sugar level. In contrast, during exhaustive marathon type of endurance exercises, blood sugar level will decrease. This is mainly because liver cannot cope up the rate of gluconeogenesis as per the demand, and as a result, the athlete has to slow down the pace or there is need for glucose ingestion. Here lies the importance of taking energy drinks during endurance training. So, even though normally glucose level will be maintained, oxygen levels are maintained, carbon dioxide levels are maintained, still after the exercise is over, there is excess of oxygen uptake. This is called as oxygen debt or recovery oxygen uptake. Why this takes place? Normally there is 2 liters of reserve oxygen present in the body. Out of this, 1 liter is in combination with hemoglobin, half liter is in the lungs, 0.3 liters in combination with myoglobin, and 0.25 liters is dissolved in body fluids. During exercise, all these reserves will be utilized. So, after the exercise is over, there is need to restore this oxygen reserve back to normal. And for this, person breathes extra oxygen or extra air. This extra oxygen intake will be utilized mainly to replenish this oxygen reserve and to remove lactic acid. So, it has got two components, lactic acid oxygen debt and lactic acid oxygen debt. Lactic acid oxygen debt occurs immediately after the stoppage of exercise. It is mainly utilized to reconstitute phosphagen system of the muscle. About 3.5 liters of oxygen consumption occurs during this particular phase. During lactic acid oxygen debt, about 8 liters of extra oxygen is consumed after the exhaustive exercise, and this is mainly utilized to reconstitute glycogen lactic acid system. So, here we finish with the metabolic changes. Let us quickly revise the changes taking place during exercise. During moderate aerobic type of exercise, there is increase in heart rate, cardiac output, systolic blood pressure as well as blood flow to heart, lungs, brain, skeletal muscles and skin. At the same time, there is decrease in diastolic blood pressure and blood flow to gastrointestinal tract as well as kidneys. There is increase in rate as well as depth of the respiration, increase in tidal volume, alveolar ventilation and oxygen uptake. Apoapsis of the lungs are converted to zone 3 blood flow and there is optimization of ventilation perfusion ratio. There is increased glycogenolysis, glycolysis, lipolysis as well as gluconeogenesis, but there is no change in blood glucose level, arterial PO2 as well as PCO2. Now let us study what are the chronic changes during exercise, or in other words, effects of training. First and foremost thing that can be seen is skeletal muscle hypertrophy. It is not only just hypertrophy but hyperplasia also. There is increase in number of myofibrils. There is increased quantity of mitochondrial enzymes, increase in various components of the phosphagen system, stored glycogen is increased as well as stored fat is increased. And all these factors help in efficient utilization of fatty acids by the muscles. Due to training, there is cardiac muscle hypertrophy, which increases stroke volume. There is increase in vagal tone, and that results into resting bradycardia. So even though resting heart rate is low, resting stroke volume is more, and so there is no change in the cardiac output. Cardiac output of trained and untrained athletes is same. There is also increase in VO2 max. It is the measure of aerobic capacity. So aerobic capacity of a person increases. In case of trained athletes, for the same intensity of exercise, there is less increase in blood pressure, there is less rise in blood lactate levels, that is delayed lactate threshold. There is lesser rise in heart rate, and this helps in continuing the exercise for longer time. Also, after the exercise, there is early recovery as well as lesser amount of oxygen debt. All these effects indicate that there is increased work capacity or increased exercise capacity. So, exercise is not just beneficial for improving cardiorespiratory endurance or developing the strength, but it also has other effects like it increases calcium deposition in the bones and bones become stronger. It releases endorphins. It also causes release of opioids, and that helps in increasing pain threshold. It increases flexibility. It delays aging process, and it helps in weight management. That's all for this session. Thank you. If you enjoy my sessions, press the like button and share it with your friends. If you haven't yet subscribed my channel, press the subscribe button. To get notifications about new releases, press bell icon. Thank you for watching.